Good morning, students. Today we are going to discuss the topic related with the prism. Now, today's topic is your refraction of light through a prism. Now, this is your prism. Its front face is in triangular shape, but left side and right side is your, you can say, the rectangular shaped. Now we are considering the front face of the prism. Now in the diagram, a ray incident on the edge AB of the front face of the prism with an angle I. Where it strikes on the prism, we have drawn a normal, and I is the angle made by the incident ray with the normal. Now it suffer refraction. Refraction definitely it is from rarer to denser. That's why the ray bends towards the normal, and the angle of refraction is your R1. Now on the edge AC of the triangular face, again change in medium occurs. That's why it suffer refraction again. That's why it suffer refraction again. And let the angle made by the refracted ray with the normal on the edge AC is your R2, and the ray that comes out from the edge AC is with an angle E with the normal. So you see the ray moves from air to glass and then from glass to air. So it is suffering refraction 2 times. Now initially you do have angle of incidence I, and then angle of refraction is your R1. Then further refraction occurs, and on the edge it has a angle of refraction R2. Now further angle of incidence is your R2. So finally it comes out with the angle of emergence, that is your E. So this is your angle of incidence, this is your angle of refraction on this edge AB, and this is your reflected ray, and this is your angle of incident, you can say, if you consider this medium and this medium, and further it reflected with the angle E. So initially from rarer to denser, then from denser to rarer. Now you see, if the prism is absent, then this PO ray moves straight, but due to the presence of the prism, this ray PO comes out along this direction, that is your O dash Q. So if you extend this one and if you extend this one, you will see that these two makes an angle delta, and delta is nothing but the angle of deviation. Okay, have you understood? I think it's very simple. We are considering this one is your air, this one is your glass, and this one is your air again. So 1, 2, 1. Now very simple geometry. If you consider this triangle OQO dash, then this is your external angle, and this 2 is your interior angle. If you consider this triangle, so external angle is equal to sum of 2 remote interior angle. So if you consider this interior angle, then this angle is your I, so this angle is also your I by vertically opposite angle. So this part is your I minus R1. Similarly, if it is E, then this angle is also E, vertically opposite angle. So this part is your E minus R2. So that's why we have written delta equal to I minus R1 plus E minus R2. So it becomes clear if you see the diagram. So check out the diagram. This is a very simple geometry. Then we have separated the terms I plus E minus R1 plus R2. Now if you consider this quadrilateral AOM dash, you will see that NM and N dash M are the normal. So these two makes an angle 90 degree each. So sum of the two angle is your 180 degree. So definitely other two angle sum must be 180 degree, because quadrilateral has 360 degree. So that's why we have written AOM AO dash M equal to 180 degree. So definitely OA definitely angle A plus, therefore angle A plus O dash is also 180 degree. Now if you consider the triangle O dash, then this is your triangle and sum of the three angle is again 180 degree. So R1 plus R2 plus O dash is your 180 degree. So if you compare 2 and 3, you will see that angle A is nothing but is your R1 plus R2 because rest terms are identical. So that's why we have written from 3 and not 4, from 3 2 and 3, from 3 and 2 you can say, okay, from 3 and 2 you can say this comes out to be your OM angle A plus angle A equal to R1 plus R2, or you can say simply A equal to R1 plus R2. So this is very important expression. Now next one, this is the condition for minimum deviation condition. Now you see deviation is your delta, no? Deviation means what? Suppose you are moving in a particular direction, but due to some reason you turned. So how much you deviated, that is your deviation. So here is also the ray strikes on the prism. Due to the presence of the prism, the ray finally comes out along O dash Q. But if there is no prism, then definitely this one goes to straight. So that's why we have extended the incident ray and the final emergent ray, and the angle made by 2 is nothing but is your deviation. So this deviation is minimum under this condition. For minimum deviation, that is if delta equal to delta m for minimum, and then I equal to E and R1 equal to R2 equal to RC. It means angle of incidence is equal to the angle of emergence, and R1 and R2 both are identical. So if you substitute this one in number 1, so delta m equal to I plus I minus R plus R, so 2I minus 2R. Also from the final A equal to R1 plus R2, so A equal to R plus R, that is your 2R. Now from Snell's law, sin I by sin R is nothing but is your diffraction index of second medium with respect to first medium. So R we have considered, that is nothing but R1 equal to R2 equal to R. So n21 sin I, in place of I we have written delta m plus 2R by 2, or 2R is nothing but is your A. So delta m equal to 2I minus A, so delta m plus A by 2 equal to I. You can use this from number 5 by substituting 2R as your A, and similarly R is your A by 2. So n21 sine of delta m plus A by 2 sine of A by 2. So n equal to sine of A plus delta m by 2 sine of A by 2. So you can replace n21 as your n. So n is nothing but the refractive index of the material of the prism, and this one can be defined by this expression, sine of A plus delta m by 2 by sine of A by 2. Now this is your graph. If you plot this graph by considering delta versus I, you will get a U-shaped graph, and the minimum value is your delta m and corresponding I is your E as per the condition. So deviation is minimum under this condition, that is I equal to E, and obviously R1 equal to R2 equal to R. So we are trying to apply this formula in the numerical. Find the refractive index of the material of the equilateral prism for which the angle of minimum deviation is 60 degree. So equilateral prism, that's why each angle is your 60 degree. So delta m is your 60 degree as per the question. So if you substitute n equal to sine of A plus delta m by 2 by sine of A by 2, sine of 60 plus 60 by 2, that is your sine 60 degree, and sine of 60 by 2 is your sine 30 degree. So sine 60 degree is your root 3 by 2 and sine 30 is your half, so 2 goes off, so it is your root 3. So refractive index is your root 3. This is very important topic for exam point of view, and in exam it is used to define this expression, final expression. So if it is asked, then you do like this, because expression carries marks rather than the statement. and also the numerical part. So this is all about, more we will discuss next class. Thank you.